Welcome back. Today we're going to look at overloaded functions, default parameterless, and variable scope. So for overloaded functions, an overloaded function makes it possible to have two or more functions with the same name but with different input parameterless. And why would we want to do that? Well, let's say that we had a program and we wanted to say goodnight multiple ways. And this is that program. And what we can see is we actually have four functions. And they have different parameter lists, but otherwise they have the same function name. And they have four function definitions, and each one does different things. So if it's the parameterless one, no parameters, notice that it just kind of gives a generic say goodnight message. If you get a name, then the second one will be called and it will say goodnight to that whatever name there came in. The third one, if you get two names, it will say goodnight to two people. And then the last one, if you provide a number instead of some strings, it will loop through that many times and say goodnight that many times. In main, it's here we see they're calling each one. And the question is, how does it know which one to call? Well, what C++ does is, it has four functions with the same name, so it has to use the parameter list to figure out which one to call. You can see in this instance, we're passing in a single string, so it's going to pick the second one. So let's run this, and I'm going to run it one time through without debug, and then one time with debug. So right now I hit Control F5, and we're going to run without debugging. So we're going to run without debugging. I'm going to hit Control F5, and we can see it ran successfully. There's our just generic call. The second one is the one name. The third one is the two name call, and then we have the function call with five of them. So let's watch this in debug mode. So I'm going to put a breakpoint right here at step 17, and then I'm going to run in debug mode, and that's Control F5 for start without that's F5 for starting with debugging. So I'm going to hit F5. And we're sitting here in front of this function. Of course, to enter a function, we're going to use step into, which is F11. So I'll hit F11. And you can see we jumped, when we call this function, it jumped to the correct one, the one without parameters. I'll hit F10 a couple times to execute its code, hit F10 again, and we can see we're back here where we're at the single parameter call with a string. I'm going to step into that function. And because I had a string, sometimes we jump into the string library. If we hit Shift F11, we can jump back out and then jump into the function again. And we can see now we're here at that function. So because we had just one string, it was able to differentiate these two functions because this one has one string parameter and this one has two. So when we do overloaded functions, what happens is C++ does a lot when it does a function call. It looks to see if there's any functions with that name, and of all the ones that it finds with that name, it then looks at the parameter list to figure out which one to call. And again, we went to the string library, so back out with that with Shift F11, step back in with, and there's two strings, so we went in twice, and finally we get to where we want to go, and we can see, yes, the two parameter one is the one that's called. And then similarly with the numeric one, because a number was passed in, the number 5 in this case, we jump in here. So let's write up our own overloaded functions, and let's write the prototypes for 2 overloaded functions called multiple chars. Both will return a string. The first overload will take 2 parameters, a char called char2repeat and an int called numchars. And the second overloaded function will take 1 parameter, an int called numchars. So you're going to write 2 functions, and they're going to have the same names but different parameter lists. So pause, try to write that down on a sheet of paper or something, and then hit continue. All right, so I'm going to create a new project to demonstrate this. Okay, so we have our function, and what we want to do is write prototypes for 2 overloaded functions called multiple chars. And let's see. So the prototypes would be, they're both going to be called multiple chars. Both will return a string. So we're going to make these string methods, and probably we'll need the string library. And let's see, we will call them multiple chars. And we're going to have 2 functions. But what's going to differentiate them is the parameter list. So one will take char2repeat as one of the parameters. The second will take, and then also we need the number of times we want to repeat it, called numchars. And then the second one will take 1 parameter, an int called numchars. And so, and this of course needs to be up here, not inside a main, because it's the function prototypes. So it looks like that. So these are what our 2 functions will look like. And then they don't have the function definitions. Those would go down here. And so those would be my function prototypes. That's all that was actually asked for by the question. But, you know, we could maybe write a little piece of code here. And maybe this other one maybe just automatically outputs an asterisk. And if we call it multiple chars, and we pass in maybe an exclamation point for the first one, and we'll do 10 of those. 12 of whatever that does. Oh, and we need a char, not a string. So it's single quote. And if I run this, let's see. Oh, we want to return a string. So actually what we want to do then is we don't want to just see out. What we want to do is say, we'll create a string. And we'll say result equals result and here we'll say we also need a string result, and then at the end we need to return that. And then here we'll again make a string result, and we will say result is equal to result plus and then what we'll do is we will just say I'm just going to make a different name so that we don't confuse the fact that this is a different variable than that one. You don't have to do that. You can use the same name, but it just kind of makes sense to me to do it that way. And then, just to show you, so one way of using a function like this is you can have this function be set into have the output of this function, which is a string, be assigned into a variable you've declared before and output it. The other way we could do this is we can actually just see out directly the results of a function, because this is a string and see out takes a string. So we can either put the results of the function into a string and then output that string, or we can take the output of multiple chars, which is a string, and just output it directly. And let's see what that looks like. And let's see, we got the exclamation points, and then we got the asterisks, and we got this on the same line because we probably should have also output an end line here. So it looks more like this. And so our function returned our 10 exclamation points and our 12 asterisks. So yes, both of those worked. We got two overloads, one that takes a number and a char, and one that just takes a number. And you see that the correct one was called. Both of them will loop through. It's just that one will use the char that was passed in. The other one will just automatically use an asterisk. So we went a little bit beyond what this one does, but it basically gives you an idea of how that works. What is a default parameter list? Well, another neat thing we can do with functions is that we can make some of our parameters be defaults. And the nice thing about that is that when someone calls that function, they don't have to necessarily provide all of the parameters. This is very useful when you have a particularly long parameter list. So the default parameter list, basically what we're going to do is we're going to put little assignment operations inside of our functions to make this work. So let's say we have a function, a draw lines program, and a default parameter list is declared for the function that prints lines of characters to the screen. And the function's job is to draw a given number of lines at a certain length with a given symbol. When it's called, it needs to know how many lines, what the symbol is, and how many symbols on each line. So we're going to say that there's a default, and we want to default the percent sign for the symbol. So if that's not provided, then we'll have the user, the function will just use percent. And then also what we want to do is we want to set a default for the number of characters on the line. So we'll set that to 25. And then the number of lines default is 1. So to do that, notice how the function prototype has these assignment operations right inside of the parameter list. This is not saying that every time you call this, symbol will equal percent, num symbols will equal 25, and num lines will equal 1. What this is saying is that if the user does not provide a parameter for symbol, then percent will be used. And if the call to the function does not include num of symbols, 25 will be used. And if the number of lines is not provided, then 1 will be used. And so this function can be called multiple ways. We can see here we have a function call where no input parameters are provided, and in that case all the defaults will be used. It'll be percent, 25 lines, and 25 symbols and 1 line. In this instance, the first 2 parameters were provided. So an symbol was provided and 30. So the symbol will be at, the number of symbols will be 30, but the number of lines, because it wasn't provided, will default to 1. In this third line, all 3 were provided. So symbol will be number sign because that was provided. Number of symbols will be 15, and number of lines will be 3. And then finally, in this one, the percent and 6 were provided. So the percent will be the same, but the number of symbols will be 6. And we kind of have to do it this way because even if we wanted to use the default, if we didn't provide it, this would be in the first position, and since symbol has to be a char, this would confuse things. So if you want to use defaults, but you want to change the second or third one, you have to, if we're just using default parameters, you have to provide them. So we can see here the results of the different function calls. So when we provided all defaults, and this is the default view with just all the defaults. When we provided 30 characters and an at, then we got 30 ats. When we provided 15, a number sign, and 3 lines, then we get this. If we provided %6, we got this. So let's give this a try. Let's write the prototype of a function called multiple chars that returns a string and takes 2 parameters. A char called char_repeat that defaults to asterisk, and an int called numchars. So think about the answer, give it a try, and then hit continue. Okay, so what we want to do is we want a multiple chars function now that returns 2 parameters, takes a char called char_repeat and that defaults to asterisk, and an int called numchars. So I'm going to just modify this first one, and what we can do is we can now say char_repeat equals an asterisk. And then you notice that this now creates a problem, because, and you see the error, default argument not at end of parameterless. In order to do this, we have to make sure that the optional parameters are always at the end. And the reason is that obviously whatever the required ones will have to be entered first. So that goes here. I'm going to get rid of this second function because we don't need it anymore when we use optional parameters. And so now this function will use, if a character is not provided, it will use asterisks. But if it is provided, then it will use whichever one was provided here. And then I'm going to change up my function call because I swapped the integer and the char to line up. And so now we should get our 10 exclamation points and our 12 multiple chars. And we can see we only have one function now, but by using optional parameters, we get the same functionality. So let's give this a try. Oh, and then also when we define this, we just need to provide it in the function prototype. So we can see we have a default parameter. It's in the function prototype only. If we, in the first function, we provided an exclamation point, notice it didn't use the asterisk because we provided it. Char to repeat was an exclamation point, and it called it passed in an exclamation point here and did the repeat. In the second one, we only provided a 12. So because we only provided 12, a number, what it did is it used the asterisk as the default and ran the loop with the asterisk. So let's run that in debug mode. And actually, I need to put a stop point before I do that. So try again. And so here we are, and we're going to step through. And the first time it calls, the question is what are we going to get for char to repeat? So if I step in, oh, let me try again. I forgot to hit F11 to step into the function. So I'm going to step into the function. And let's see what it got. We can see that char to repeat got the exclamation point, which is this one here. Notice that because the char is really numeric, we're actually passing in 33, which is the ASCII code for exclamation point. But it shows us what the exclamation point as well. And so I'm going to then step through, and it will step through all of these functions. Actually, if I don't want to step through continuously, I can just put a breakpoint, and then I'll hit F5 to just step through all that. I'll hit F10 again. And now we're going to step through, and we're into this multiple chars. And so now we're going to call it, and the question is, what is char going to be? We haven't provided another character here. So I'm going to step in, and if we look at char to repeat, we see that it used the default here, asterisk. So char to repeat was given the value asterisk because it wasn't provided in the function call. It used the default. So that's why we call this a default parameter. It looks like an assignment operation, but this is really just assigning a default parameter. Variable scope. So what is the scope of a variable? We kind of talked about this a little bit in earlier presentations. But the variable scope determines which variables in the program are visible to other portions of the program and dictates how long a variable is visible. And what we're going to see is that variables generally are visible within the function that they are defined. Variables that are defined inside of functions are called local variables. And local variables have what you call block scope. So they exist within the set of braces that define them. By the way, this is not only the braces for the block of code that they're defined in, but also for the function they're defined in, but also for, if a variable is defined inside of an if statement, or if it's defined inside a loop, and it's defined inside those curly braces, it only exists within those curly braces. So here we can see the name variable is global. And so here we can see some examples of this. Name variable here is actually what we say is a global variable. Notice it's defined outside of all functions. If you declare a variable outside of all functions, they're global. Int count is declared inside of main, so it only is visible and exists within the curly braces of main. Here, int I is defined not only within a function, but inside this if statement. So the I here only exists within this if statement. So the way I think about it is this. If I want to see where the variable is visible from, I look at it and it's visible from anywhere inside any of the curly braces that it's been defined in, and you can go into any other set of curly braces. For example, in this for, you could see the I because it was, you can go up the curly braces, but you can't go around. So you can't see, for example, this variable count, which is defined inside of main, is not actually visible directly from main. It had to be passed in as a parameter for this function here to see this variable count. And also note that this is actually a different count than this one. This is a different place in memory. It's just copied over. So let's look at it this way. Here we have say hello, we have main, and so we're starting off with name defined at the global level. So name is going to be visible throughout. It's generally considered a bad idea to do this, by the way, because since this variable never gets destroyed, it's going to take up memory throughout the existence of the entire program. We actually like the idea of variables of becoming non-visible periodically because it saves memory. So now we set the name Bob into name. We initialize a variable called count. And then we call say hello, and we're passing the value count into it. When we go to say hello, another variable called count is created, or as a parameter for say hello, and the value 5 is actually copied into this. This count here is different than this count, the parameter here. We now go in and you can see that it checks to look at the value of name. If it equals Bob, it does equal Bob. We create an integer and we start looping through here. I didn't run the instruction pointer around, but you can see it looped in. It's going to loop about 5 times. So we get the 5 loops. And now we go down to the end of the program. And you can see that I is no longer in scope. So it disappeared. Let me go back through there. You see here we have I. It's visible. As soon as we jump out of these curly braces, I is no longer accessible. When we return back to main, note that the count that was existing here is no longer visible, although this one would be visible. And then we come back. So a global variable is declared outside any function and is visible to all functions in that program file. All the functions can use and change that global variable because it's going to exist throughout the existence of the program. And to declare a global variable, you just declare them above your main function. There's no need to pass them between functions. So here's an example of a global of two global variables. We have age and name. Notice they're declared outside of main. All these functions can access age and name. And so this might seem like a nice convenient way of avoiding having to use all this parameter stuff. However, there's some disadvantages to that. Let's take a look at these functions. First of all, notice that, do we have any idea what write hello, ask for name, ask for age, and write use? Not really. And so here we can see, and then we don't really know what these things return because they're all declared as void. If we were to write functions this way, you could see that you would just work with the global parameters right away. But the problem with global variables are, one, it makes the code harder to read, and two, it uses up a lot of memory because the variables will have to be in existence for the entire duration of the program. And so global variables should be used sparingly. In fact, I would recommend avoiding them completely as much as possible. As a general rule, you might use global variables for mathematical constants or use universally used values, maybe file pointers or stream objects, but you're probably better off by using using a define directive rather than using a global variable or constant, since the global variable is going to use up memory when you don't need it to. So generally speaking, avoid global variables. And in my course, I'm going to ask you to not use them. Another type of variable are static variables. And once a variable is declared as static, the variable are retained until the program terminates. So normally when you leave a function, all the variables in that function are garbage collected and they're thrown away. So you don't get to retain the values that are in those functions from one call to the next. And so every time you revisit the function, you get a brand new variable and it has to be reinitialized. Sometimes, though, you want a variable to retain its value even after the function has stopped executing. And to do that, we use something called a static variable. And the way you use a static variable is you use the static keyword. So if we say static float total equals some value, this variable will stay in memory even after we exit a function. And so here we have a function, and it declares a variable inside this function called total. And we have static cast float, and we have its starting value. So this will make a variable total that will be initialized to 0.0. We can then have just some code here which asks how much was this recent purchase, gets the value, and then we see that with this total inside this function, we're going to accumulate whatever amount is input into this total, and it returns the total. So this function just keeps accumulating a total and always returns it. And we can use the static keyword and static cast in order to keep a variable. The reason why we have to use this special syntax here is because this line will only be executed one time. The variable will be declared one time. The first time this function is called, it'll be declared, and then the line will not execute again because it won't redefine the variable and therefore get rid of what's currently there. So this is how it preserves the value. And so if you run this one over and over again, what will happen is every time you call the function, it will keep adding to a static variable that stays in memory even after the function has left. So let's look at the following question. Variables declared in a function have which of the following scopes? So inside a function, if you declare a variable, what scope does it have? Global scope, accessible throughout the program, or local scope, accessible only in that function? Pause, think about the answer, and then hit continue. Well, the key here is a variable declared in a function. If it's declared in a function, it's only accessible in that function. To be global, you'd have to declare it outside any function. When should you use global variables? Always? Then you don't have to worry about access. Boy, wouldn't that be convenient? Never. It's always a mistake. Sparingly, with considerable thought as well as subsequent documentation, or none of the above. So pause, think about the answer, and then hit continue. The answer is sparingly. And really, you almost want to think of it almost as never, but sparingly is really the right answer. And you should, in my class, please don't use global variables. I won't be giving you an assignment that requires them in C++1, but you really should try to avoid using global variables. So please, after this, complete the overloaded functions demo. And what we discussed today were overloaded functions, some default parameter lists, and some variable scope. Thank you very much.